Try to get everybody loaded in here. Got a couple of people that we're waiting on. How is everybody? Everybody enjoy your week off?
Yes.
Everybody ready to come back to school?
Yes.
Let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 4 more we're waiting on. Give it a couple more minutes. You can hear that wind whipping outside. Good day to not have to go out. I'm glad to be able to stay in, not have to get out in this yucky weather. In just a minute. Hi. Here comes Zoe. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Trying to remember, I know Chad was going to be out today, so it'll be 12. So we've got 2 more. Hopefully they'll log in shortly. But all righty, we'll go ahead and get started. So anyway, I hope everybody had a wonderful week off. I hope you got to rest. I know I stayed in my pajamas way too long each day, but it was great just to not have to worry about anything and be able to relax a little bit and just enjoy being home with family and all that good stuff. And if you guys traveled, I hope y'all had a good trip. Here comes Jonas. But anyway, so we've had a nice little time to rest, and now we're going to get back at it. We've got 2 weeks until we get out for Christmas break. So we're going to get a good bit covered. We'll start out with kind of reviewing what we left off with, and hopefully you've had a chance to check your homework, look at any questions that you may have. We'll be wrapping up our unit on graphing and having our test on graphing. That'll go home on Thursday. And I'll be talking with you guys about what to be prepared for with that and all that good stuff. And then we will be working on a section on inequalities, and then that will kind of wrap us up for the end of the year. So let's see, best way to do this. What I want to do is I want to kind of flip back a little bit and kind of review what we have done so far up to this point, kind of talk through, let you guys ask any questions that you may have if there's anything that you're not quite sure about. And then once we've kind of done a little review of the different lessons that we've done, then we'll go ahead and look at the homework that I sent the answers for last night and look and see if we have any questions on that. So in your book, let's flip back. We're going to go pretty far. Go back to lesson 29. Okay, that's on page 63, lesson 29, page 63. We're just going to kind of do a quick little scoot through review. Get our brains geared and focused again on graphing. So in lesson 29, page 63, we learned about the coordinate plane. We learned that there is an X and Y axis that breaks our grid or breaks our plane into 4 different quadrants. And we've talked about how each quadrant has different positive or negative values based on is it to the left of the origin, the right of the origin? Is it above the origin or below the origin? And we talked about how the origin is 0.00, where those 2 lines intersect, okay? So then on lesson 30, page 65, we learned that When I have my values, my ordered pairs are X and Y, when I graph those on a grid, but we also learned that sometimes we can use our equations and we can plug a value in for one, and we did that with X. We plugged in different values for X and we were able to solve for Y. So when I had a value for X and I solved for Y, that gave me another ordered pair that I could graph on my grid. And whenever I am using, oh, and y'all have to, my clock will be chiming. I usually don't keep my grandfather clock wound, but as we were getting ready for Christmas and prepping and stuff, my son insisted on winding the clock. So anyway, so hopefully we'll get used to it pretty quick. So in lesson 30, we were just looking at plugging in values for X and solving for Y, graphing those and seeing how they graph to make a line. And that is why we call them linear equations, because they are equations that graph in the shape of a line. Okay. We also talked about how when I graph those points and I connect the dots and I make a straight line, I put arrows on either end to understand that it extends indefinitely in both directions. All right, let's jump on over to lesson 31 on page 69, dealing with slope. We've learned that the slope describes the steepness of a line. And we talked about how when I'm looking at slope, we are looking at rise over run. We're looking at the vertical change over the horizontal change. So when I'm describing my slope, a lot of times I put that in the form of a fraction. My number on top tells me if I'm going up or down. My number on the bottom, or the denominator, tells me if I'm going left or right. Up and down is determined whether it's positive or negative. Same with left or right. If I'm going up, it's positive, down is negative, left is negative, right is positive. So thinking about, is my slope positive or negative, and how I can change around those negative signs, where I can put it in the numerator or I can put it in the denominator to be able to go different directions when I'm graphing. Also with slope, we talked about how we let the letter M represent a slope in an equation. That's so like y equals mx plus b, the value of slope is going to be the letter M in our equation. We also talked about how if I have a horizontal line, horizontal means it runs from side to side. Here comes Miss Sadie. Horizontal means it's running side to side. And if I have a horizontal slope, we know that is equal to 0, because there is no change up and down. There's no vertical change. There's only horizontal change from side to side. And then we talked about how the slope of a vertical line, we call that either no slope or undefined. Either one, that's just our straight up and down line. A vertical line has no slope. The reason we learned that it has no slope is because when I calculate the slope, there is a 0 in the denominator. And remember, division by 0 is undefined. So if you are calculating a slope and you have a 0 in the denominator, you know you're dealing with a vertical line. If you have a 0 in the numerator, you're dealing with a horizontal line. All right, let's look at lesson 32 on page 71. This is where we talked about the y-intercept. We talked about slope-intercept form, y equals mx plus b. In this equation, we learned that, again, we've already talked about m represents the slope, but our variable b tells us the value of y in the y-intercept. We also learned that x is always 0 when we're describing the y-intercept. Okay, so whenever I have a y-intercept, x will be 0, and whatever the value of y is what is represented in our equation as the letter b. Okay, remember that in our equation, y equals mx plus b. In the standard equation, it is plus b, so if I have minus b, I know that my number is negative. At any point that you have questions on anything that I'm going over, raise your hand, unmute, and ask a question. Let me know. Okay, I'm just doing this to kind of get us back on task so we can finish up. Page 73, lesson 33, we dealt with point slope form. And remember, this is when I have a slope and I have a given point. Point slope form is y minus y1 equals m times x minus x1. And I use this equation in two different situations, okay? One situation is when I look at your classwork on lesson 33, you can see where they gave us a slope and they gave us 1 point. I can use point slope in that equation. I can also use this when I'm given 2 points. But I know that if I'm given 2 points, the first thing I have to do is calculate the slope. Then I choose one of my points to represent a point, and then I can put it in point slope form. Lesson 34 talked more about horizontal lines and vertical lines, and how we can, when I'm writing the equation of a horizontal line, I know that I'm just going to have y equals a number. If I'm writing the equation of a vertical line, I'm going to have x equals a number. And that's because if I have y equals something, I know that my slope is 0, so that mx plus b is gone away, or just mx is gone away. Same thing with x equals something. I know that, that I have no slope there. Lesson 35 on page 77, x and y intercepts. Again, we've already talked about how the y-intercept, my value of x is always 0. And then the letter, whatever number I have for b is my y-intercept. When I'm talking about an x-intercept, I know that y is always 0. And so, and then my number that's represented for x is where I move along my x-axis. Okay, so x-intercept is where my line crosses the x-axis. My y-intercept is where my line crosses the y-axis. Moving on to 36, page 79. On page 36, and on lesson 36, page 79, we talked about perpendicular lines. And we have previously learned that when I'm dealing with perpendicular lines, these are two lines that intersect, they cross over each other at a 90-degree angle, okay? So where they intersect at a 90-degree angle, that tells me that their slopes are going to be different. And so when I have perpendicular lines, this is where we learned that the slope of perpendicular lines are called negative reciprocals. One will be positive, one will be negative. One will be a number in one form, and then the other one is going to be flipped. Okay, so the reciprocal of that. Lesson 37, we talked about parallel lines. We talked about how parallel lines are lines that run alongside each other and they never intersect because the distance between the two lines is consistently the same all the way. And so because they're consistently the same distance, we learned that the slopes of parallel lines are going to be the same. They have to be the same so they never intersect, okay? Perpendicular lines have slopes that are negative reciprocals. Parallel lines have slopes that are exactly the same. Lesson 38, we talked about standard form, ax plus by equals c. And we learned that when we write an equation in this form, there are several things that I have to make sure about. The first one is that my letter a has to be greater than 0. So that means it can't be negative, it can't be a fraction. It has to be a whole number greater than 0. Okay, we also learned that I cannot have any fractions or decimals anywhere in the equation. So if I have a fraction or a decimal, I have to clear those. Okay, so those were our two big things that we had to make sure of when I'm going to standard form. Ax plus by equals c. A has to be greater than 0, and I cannot have any fractions or decimals anywhere in my equation. Okay, 39. This is where we started working. Instead of graphing equations, we shifted to writing equations. We went from having an equation and being able to put it on a graph to having an equation on a graph and being able to write an equation based on the information that we looked at. So there have been several things that we've done for lessons 39, 40, and 41. And this is where our homework came from this past week. So one of our first things, sorry guys about the phone, I need to shut the ringer off. So the first thing we looked at is when I look at a graph, I want to identify, number one, is there a y-intercept? If there is, I write it down. The second thing I do is if I don't have a y-intercept, I want to identify at least 2 points on that line. Write those down. If I have 2 points on my line, then I can find my slope. I want to write that down, okay? So if I have a y-intercept and a slope, I know that I can write the equation y equals mx plus b. If I have just 2 points, I know that I can find my slope and I can put it in point slope form. And either whether I'm using slope intercept or point slope, we've learned how to change those from that form to standard form, okay? AX plus BY equals C. So we've done a lot with these. We figured out how to be able to look at a graph and how to be able to pick out which equation I need to write first, and then to transfer it to standard form. So now what I want to do is go ahead and let's take a look at our homework. We had page 86, and we had activities 3 at the top. And then in activities 4, we had numbers 4, 5, and 6. So go ahead and look at your page 86. Let me go ahead and pull up those answers real quick, and we'll take a look at those. Now, one of the things I mentioned in the email that I sent with the answers was I just sent the answers. I did not show the work to convert from slope intercept to standard form or from point slope to standard form. So I need to see your work when you turn it in. I need to be able to see what you did. Let me get this pulled up real quick. Let's see. And remember, I said that we would be talking, we'll talk probably today and also later on Thursday. We'll definitely make a list of all the work that will be due next Monday when we return to the co-op. Let's see, these are homework answers. Page 86 and 80. Oops. And then now I need to share my screen. Okay, so first we're going to go through these homework answers, look and see if we have any questions. This is what I sent you guys. At the top, I just put page 86, activities 3, activities 4, numbers 4, 5, and 6, and then page 88, activities 2. There were 4 things that you were supposed to do for each of these, and the first thing was to identify a point. It could have been the y-intercept. It could have been any other point. The second thing was to count your slope. You could either use your equation of m equals x2 minus x1 over y2 minus y1, or you could have just counted your slope to get from one point to another. So the second thing was to be able to find that slope, and then use point slope form, and then convert to standard form. All right, so let's go ahead and look at page 86, activities 3. They gave us 2 points on this line. And so in page 86, activities 3, I have a y-intercept. So my y-intercept is the point 0, -3. I could either count to get from 0, -3 up to our other point, which was 2, 0. I could either count it, or I could use my formula, m equals y2 minus y1 over x2 minus x1. So I could either use my slope formula or I could count it, and I found that the slope was 3 over 2. Using that information, I just plugged in my slope for m, and I plugged in my value of b that I found in the y-intercept. Any questions on number 1 on page 86? Okay, let's look at number 2. So number 2, I have another graph there. I can see that I've got my slope, my y-intercept is actually at the origin, which is 0, 0. So the origin was where my line is crossing over the y-axis. So my y-intercept is 0, 0. Looking at my other point is -1, 2. Okay, so I have -1, 2 is my other point. No, it's not. Yes, it is. And then I could either use my slope formula, or I could just count my slope. And I know to get from the origin to my other point, I went up 2 into the left 1. So that would be a +2 over a -1, which just simplifies to a -2. So then when I plug that in, I could have y equals -2x plus 0. Or I can just simplify that and I can leave the 0 off and just have y equals -2x. Okay? So any questions on number 2? All righty. Now we went on to activities 4 at the bottom. And so like I said, there is work to be shown here on your paper. I need to see where you get from your equation to standard form. Okay, so that's why I put the 2 little arrows there to imply that there's more work for you to show. I will not just accept answers on this. So please make sure you do the work. So on number 4, we saw here that they gave us a slope and they gave us a y-intercept. I can use slope intercept y equals mx plus b. So I plugged those values in and have y equals 3/5 x plus 1/4. Now to go to standard form, what is wrong with what I have right now? What do I have 2 of that I cannot have in standard form?
Fractions.
Fractions. Yes, fractions. I cannot have fractions. So I've got to be able to clear my fractions. In that I have a denominator of 5 and a denominator of 4. Remember, to be able to clear 2 different numbers in my denominators, I have to multiply by a number that both of those are divisible by, or that will divide into. So in that situation, my common denominator is going to be 20. So I have to multiply my entire equation by 20, clear my denominators, then I can do my moving around, and you should end up with 12x minus 20y equals -5. Any questions on how I got there? Any questions on that? All righty. Number 5, same thing. They gave us a slope, but this time they gave us just a point. They did not give me a y-intercept, so I know I'm using my point slope form. Y minus y1 equals m times x minus x1. So I'm plugging in my value of my slope, which is -2/3. I plug in my point, which is -3, -2. So again, because my original formula has, actually, let me find my pen. Since I have y minus y1 equals m times x minus x1. Since my original equation has negatives, it becomes positive when I insert a negative number. Same thing here. My original equation has a negative, so it becomes positive when I insert a negative number. Now, when I'm starting with point slope form, I know I have to distribute, but then I've also got to clear my denominator, okay? So going from point slope to standard form, there's some work to be done there, but you should end up with 2x plus 3y equals -12. Any questions on that one? Did you have any trouble converting? All right, and then number 6. Number 6, they only gave us 2 points. And like I said, if I only have 2 points on the line, the first thing I have to do is I have to solve for the slope, because I know that in any equation, I've got to have my slope represented. So the first thing I had to do was find my slope. So I used my slope formula of y2 minus y1 over x2 minus x1, and I found that my slope was 12 over 5. So then what I did, notice that I used both of my points. So since my points, I had -2, -5, and then I also had 3, 7. The first one is where I plugged in if I used points -2, -5. Okay, so you could have used that as your point and use your slope. And then 3, 7, I went ahead and did another equation just in case you chose to use that point. Either way, whether you use point 1, whether you use this one as your point or this one as your point, your standard form for both of them will end up being 12x minus 5y equals 1. So it does not matter which point you used for your point slope form. Either one will end up converting to standard form 12x minus 5y equals 1. Any questions on that one? That problem required a little more work because we had to first calculate our slope, then we had to put it in point slope, and then we had to go standard form. So any questions on page 86? All right, moving along to page 88. So flip over to 88. We had just activities 2. We had our 2 equations. And so with these, I told you I needed you to identify a point. I needed you to identify the slope. I needed you to put it in point slope form and then convert to standard form. So in my first one, again, you could have identified point -2, or you could have used 0.11. Either way, you should have found that your slope was -1/3. When I plug in point -22, I would have y minus 2 equals -1/3 times x plus 2. If I would have used 0.11, you would end up with y minus 1 equals -1/3 times x minus 1. Either way, whichever one you chose to use, standard form would end up being x plus 3y equals 4. Again, I want to see your work on how you got from 3 to 4. Okay, you must show your work on how you got from your equation in step 3 to step 4. Any questions on that one? All right, and then the last one, same thing, identify a point. I went ahead and put both of them, so you just had to identify one, calculate the slope, put it into point slope form, and then go to standard form. So again, show your work from steps 3 to 4. Any questions on that one? All righty. So now what we're going to do, lesson 41, we tied 39, 40, and 41 all together. All of them dealt with converting to standard form. I don't see any point in going through this section any longer. So we're just going to move on. And let's go ahead and look at page 92. Page 92, activities 2 will be your first part of homework. Let me find a place. I'm going to make a list. So page 92, activities 2. Now, I just want you to look at that. Okay, let's look at that for just a minute. Page 92, activities 2. Your directions just say to write an equation of the graph in standard form. Okay, so that's all I'm going to be looking for, but I must see your work on how you got to standard form. So let's look at our graph, the first one. Let's number those as 1, 2, and 3. And what I'll do, let's see. So this is page 92, activities 2. We're going to number them 1, 2, and 3. Now, if you look at graph 1, remember this is where I go through my steps and say, hey, can I identify a point? Yes, I can. I can identify 2 points here. One of them is not the y-intercept. So I have 2 points that I'm able to identify. So for number 1, first, you need to identify a point. Second, you're going to need to find the slope. It could be using the slope formula. It could be counting the slope. Third, you're going to use point slope form. And fourth, you're going to convert to standard form. Okay, so for activities 2, that's what you're going to need to do for each of these problems. Okay, you're going to have to be able to convert to standard form. You've got to go through this process. So make sure you write down step 1, identify the slope. Identify a point. Step 2, find the slope. Step 3, point slope form. Step 4, convert to standard form. So basically exactly what we did in activities 2 on page 88. Okay, so I'm going to put same as activities 2, page 88. Any questions about that?
Do we need to do lesson
Good on
notes
that?
for this since we've already done it?
All righty. Now let's go ahead and turn over to
Hey, Miss
lesson
Jennifer.
42 on page 93. I'm going to go back. Okay, so lesson 42 on page 93 is writing equations of perpendicular lines. Okay, so what we're going to do is let's look at this. It says, recall from lesson 36 that perpendicular lines have slopes that are negative reciprocals. So go ahead and let's underline that. Perpendicular lines have slopes that are negative reciprocals of each other. Okay, so it says to write an equation of a line perpendicular to a given line on a graph, follow these steps. Number 1, find the slope of the given line. So we're going to put that as number 1. Number 2, find the negative reciprocal of the slope. Number 3, choose a point on the given line and write the equation in point slope form. And then 4 is to convert the equation to standard form. So just like we did in our previous homework, just like we're going to do on page 92's homework, we're doing the same 4 steps that we did previously, except for this time I've got to give a negative reciprocal, okay? Because I have a given line and I'm trying to find a line that would be perpendicular to it. So the only things that would be, or the main things that are different about those 2 lines are going to be the slope. So let's practice this. All right, so it says to write an equation in standard form of a line perpendicular to the given line. So let's look at our steps that we just looked at. So step 1, first of all, here it says to find the slope of the given line. All right, so I'm going to go ahead and start out looking at my 2 points, and I'm going to identify my 2 points on my line. So my line that is at the top, I see that I'm going left 1, up 2 from my point. So that means it is -1, 2 is that point. Okay. And then my point below it, or my second point on the graph, I have to go right 1 and down 1. So I know that that ordered pair would be 1, -1. Okay, so those are my 2 points that I can see. I can either count my slope. Let me erase this real quick and we'll count it real quick. I can count my slope. Let's count. Or I can use my equation. If I want to just count it, remember rise over run, M equals rise over run. So that means rise is up or down. I'm going down to get to my second point. So I've gone down 1, 2, 3 places. So I went down 3. So that's going to be a -3. And then I go right 2. So that's going to be a +2. So I know my slope equals -3 over 2. Now again, I could have used M is equal to y2 minus y1 over x2 minus x1. And I could have used my numbers and said, hey, I've got 2 minus a -1 over -1 minus 1. 2 minus a -1 is the same as 2 plus 1, so that gives me a 3. -1 minus 1 is a -2, so that's a -2. So either way, whether I count it or I use my equation, I'm going to find that my slope is -3 over 2. So that was the first thing it told me to do, is find my slope, which is -3 over 2. Okay, Now, step 2 says to choose a point. Okay, I could choose either point -1, 2, or I could use point 1, -1. It doesn't matter which one I choose. I can choose either one. Now, step 3 tells me I've got to use my slope and one of my points, and y minus y1 equals m times x minus x1 point slope form. So I could have y minus 2 equals -3/2 times x plus 1, or I could use y plus 1 equals, now this is going to be the time that it chimes every single time since it's 11 o'clock and it's going to chime 11 times. I'll go ahead and write while it's chiming. And plug my slope in, 3/2 times x minus 1. I think there is a way that I can turn that chimer off. I'm going to have to do that. Okay, so again, it doesn't matter which ordered pair I choose to plug in. When I plug in -1, 2, I end up with y minus 2 equals -3/2 times x plus 1. If I plug in 1, -1, then I have y plus 1 equals -3/2 times x minus 1. Any questions on how I got there? Does everybody understand how to take your information and plug it into that equation? All right, so step 4 is where I have to convert to standard form. And so what I want to show you is that it really doesn't matter which equation I start out with. So I'm going to start with my first one that I used, which was y minus 2 equals -3/2 times x plus 1. So I would go ahead and start out here by distributing and have y minus 2 is equal to -3/2 x minus 3/2. Okay, I distributed that -3/2 to both sides. Now I've got denominators. I need to clear those denominators. I'm going to multiply everything by 2. So I'm going to have, I guess I'll just write small. I'm going to have 2y minus 4 equals -3x minus 3. Okay, I've multiplied everything by 2. So I know that I need to move 3x to the left-hand side. So I have 3x plus 2y minus 4 equals -3. Now I need to add 4 to each side. So I end up with 3x plus 2y equals 1. Okay, that was plugging in 1 point. Now I'm going to move over and let's see, I'm going to do y plus 1 equals -3/2 times x minus 1. I'm going to come over here and use this little area. Okay, so now I'm doing the other one. And I have y plus 1 equals -3/2 times x minus 1. Again, I start by distributing. And I have y plus 1 equals -3/2 x plus 3/2, since a negative times a negative is a positive. Again, I have 2's in my denominator, so I need to multiply everything by 2. And I have 2y plus 2 equals -3x plus 3. Now, for standard form, I've got to move that 3x over. And I have 3x plus 2y plus 2 equals 3. I need to move that 2 by subtracting, and I end up with 3x plus 2y equals 2. What? I subtracted 1. What in the world did I do? Sorry. Let me erase that. I knew it was going to end up being a 1, and it, man, my brain and my hand are working funny today. Subtract 2, subtract 2. Now 3 minus 2 is 1. So I ended up with 3x plus 2y equals 1. 3x plus 2y equals 1. It doesn't matter which ordered pair I choose to plug in for point slope. For standard form, I'm going to get the same exact equation. Okay? So the first thing we did in this problem was we identified the slope here. We counted our slope or used our slope formula. We identified a point. We plugged those two pieces of information into point slope form, and then we converted to standard form. Now, I messed up here. All I did was go through this one. What did I mess up here? What was I supposed to do in step 2? I jumped ahead. Step 2, I was actually supposed to find the negative reciprocal. Okay, so let's take a look at that. Since I kind of changed up my steps a little bit, what should my negative reciprocal be of negative 3/2? That would be 2/3, right? Because my first one is negative, so this one has to be positive, and then I've got to flip it. So now what we're going to do is, knowing that, let's come over and let's take a look at how that would change our equation. And what I'm going to do is I'm going to get a, let's see, let's look at this one. Well, actually, we'll just plug it in over here. We'll look at each of them. If I were to change my equation here, notice this would be a positive 2/3. So I'm going to change this to positive 2/3. Actually, I think that's going to make it a little more confusing. Let me just get a brand new sheet of paper real quick. And what I'm going to do is, where's my pencil? Y minus 2 equals, it was negative 3/2 times x plus 1. So what I'm going to do is I'm going to start where we were. We had y, well, minus 2 equals negative 3/2 times x plus 1. To do my perpendicular line, I'm going to have y minus 2 is equal to 2/3 times x plus 1. Okay, this is for my perpendicular line. I have to use my negative reciprocal. So again, I'm going to do everything exactly the same as I did and have y minus 2 equals 2/3 x plus 2/3. I need to multiply everything, clear that denominator, and I'd have 3y minus 6 is equal to 2x plus 2. Subtract 2x, subtract 2x, and I have negative 2x plus 3y minus 6 is equal to 2. Now I'm going to add 6, and I have negative 2x plus 3y is equal to 8. Now here, I know my negative cannot be there, so I have 2x minus 3y equals 8. All right, that was doing one point. Now the other one, I had y plus 1 is equal to negative 3/2 times x minus 1. Now I've got to do my negative reciprocal, and I have y plus 1 equals 2/3 times x plus, oh, nope, go away. Minus 1. I need to distribute. Y plus 1 equals 2/3 x minus 2/3. Again, I've got to eliminate my denominators. 3y plus 3 equals 2x minus 6. Subtract 2x, negative 2x plus 3y plus 3 equals negative 6. Subtract 3, subtract 3. Why did I put, y'all, I'm not working well this morning. That should not be a negative 6. That should just be a negative 2. let me back up a little bit and reset. Okay. Y plus 1 equals negative 3/2 x minus 1. Then we distribute, and I've got y plus 1. I'm changing my reciprocal to my slope to 2/3 times x minus 1. I'm going to distribute, and I end up with y plus 1 equals 2/3 x minus 2/3. Clear my denominator by multiplying everything by 3. 3 times y is 3y. 3 times 1 is 3. That becomes 2x, and that becomes minus 2. All righty. Now I'm moving my 2x, so I have negative 2x plus 3y plus 3 equals negative 2. Subtract 3 from each side. Negative 2x plus 3y equals negative 5. Now I've got to change my signs and have 2x minus 3y equals 5. So notice that when I get to standard form here, I am going to have different numbers based on what which point I chose, because it's dealing with the reciprocal. Okay. So let's try to do another one and not make it quite as confusing. I'm so sorry about that. Let's go back through that. So let's wipe the slate clean and start again. Okay, classwork 1. Write equations in standard form of the lines perpendicular to the given line at each of the points shown in the graph. So let's start this over. So step 1, I need to find my slope of my line that I have right now. Okay, so I'm going to find the slope. To get from this point to this point, I'm going down 1, so that's negative 1, and right 1, which is a positive 1. So I have negative 1 over 1. Okay, so now to find the negative reciprocal of that means I'm starting with a negative, so I know my negative reciprocal will be positive, and 1 over 1 is still just going to be 1 over 1. So I went from a negative 1 as a slope to a positive 1 as a slope. Okay, so that's our first thing, is now we are working with our negative reciprocal slope. All right, step 2, let's look at our points. So I've got 0, 3, which is our y-intercept, and I have 1, 2. All right. So I can either do point slope, or I can use slope intercept. Since I do have a y-intercept, I can just use slope intercept. What we'll do is I'll go ahead and give an example of both of them. Okay, so the first one we will do is going to be slope intercept. So I could go ahead and say, all right, I've got y equals mx plus b. So in that I have y equals, now remember we're writing the negative reciprocal this time, so I have my slope of 1 times x, and I'm using 0, 3 as my point. I'm using my y-intercept. So I have 1x plus 3. Okay, so now I just need to go to standard form. So I subtract x from each side, subtract x from each side. So I have negative x plus y equals 3. So that means now I need to go x minus y equals negative 3 is my standard form. So this was step 3. This was step 4. I could have done that, or I could have used my point 1, 2, and I could have gone with, in step 3, I could have said y minus y1 equals m times x minus x1. And I could have plugged in and said y minus 2 equals, m is 1 times x minus 1. Distribute my 1. Y minus 2 is equal to x minus 1. Subtract x, negative x plus y minus 2 equals negative 1. Add 2, and x plus y. Again, I wrote down a 2 over here, and I just don't know why I did that. That was a negative 1. And negative 1 plus 2 is positive 1. So had I chosen, notice whichever one I would have used, if I would have gone from slope intercept, if I would have used 0.03, I would have ended up with x minus y equals negative 3. And if I would have used 0.12, I'm going to have x plus y equals 1. So the main thing with that is you only have to use one of them. You can choose which one you want to use. And I will be looking to see, so like if you have a question, and actually, to be honest with you, I'm not going to put perpendicular and parallel lines on the test, okay? I just want you to understand that earlier when we were looking at converting, if we were using the same 2 points on a line, my standard form is going to be the same because I'm using 2 points on the same line. Now, in this situation, the reason my numbers are different is because, let me erase this real quick, real good so y'all can see. Because when I'm drawing these slopes, or I'm drawing these equations, the reason they're different is because, remember, I just drew a line that would look like this was one of them, or this. Millie. Sorry, it's the UPS man. Millie. Okay, sorry about that. So the reason that I end up with different equations when I go to standard form is because I've actually shown 2 different perpendicular lines, or 2 different lines that could intersect with my original line that are perpendicular. Okay, so that is the reason that these end up being different equations at the end when I go to standard form. Okay, but you do not have to show both of them. You do not have to write an equation of a line that is perpendicular at both points. You just choose one. Okay, so in the first one, when I used my y-intercept, that is this red line right here. This would be a line that is perpendicular to the original line. It intersects here at a 90-degree angle. Then my second one that I chose to use was this other point, and that is why it intersects at a 90-degree angle going through that point. Okay, so perpendicular lines, the main thing to know here, negative reciprocal slopes, they intersect at 90-degree angles. Okay. So the next thing we're going to look at is on, let's see. And actually, let's go ahead and turn over to page 94 for a minute. I don't have that picture, but real quick on 94. What I want you to do first is let's go ahead and calculate the slope of the first graph. So we've got 4 graphs here. And so this is on page 94. Let's look at the first one. Let's calculate the slopes of each of these. Or let's look at what the slope of the perpendicular line would be. So in my first one, I've got 2 points. Actually, I've got 3, don't I? Because where does it intersect? Where does it cross over? It crosses over at my origin, which is 0, 0. So really, I can see that I've got 0, 0 as a point. I can see that I've got 1, 1 as a point, and I've got -1, -1 as a point. Okay, so my slope of this equation is going to be if I count it, my slope is -1 over -1, which is equal to 1 over 1, which is equal to 1. Okay, so my slope of my line is 1. What is my negative reciprocal going to be of this line? What's the negative reciprocal of +1? It's just going to be -1, isn't it? Okay, so all we're doing right now is just looking at our negative reciprocals. We're not even going to worry about writing an equation here. Let's look at the graph next to it, to the right-hand side. Okay, so if I'm looking at the second one on the top row, I can see that I've got ordered pair. My first one, I've got 0.10. I also have point -1, -1. So if I wanted to calculate my slope, I'm going down 1, and then I'm going to the left 2, which will be a -1 over -2, which is also a +1 over 2. So what is my negative reciprocal of this one going to be? If my original is 1 over 2, then my negative reciprocal will be -2 over 1, which is just the same as -2. Okay, so basically I'm looking at what it would look like. What would my slope of a line be that's going perpendicular to those? All right, let's go ahead and move on to lesson 43 on page 95. And I guess I need to check my time, don't I? Because I bet it's break time. We're probably past it. All right, let's take 5 minutes for break, and then we'll come back to lesson 43. All righty, let's get ready and come on back. And now we're going to go ahead and take a look at lesson 43, dealing with parallel lines. And so here, parallel lines, remember, parallel lines have the same slope or equal slopes. So that's the main thing here. It says, recall that from lesson 37, parallel lines have equal slopes. So it says to write an equation of a line parallel to a given line on a graph, follow these steps. Number one, find the slope of the given line. Okay, so that's the first thing, is you're going to find the slope. Number two says choose a point not on the given line. Okay, so here you're choosing any point that is not on that line. So basically, if I was looking at this picture here and I said, hey, I want to choose this point right here, I could choose that one. I could choose this one. I could choose any point that's not on that line. It does not matter which one, okay? I can choose any kind of point there. So that's number two. And then it says, and write the equation in point slope form. And then it says the easiest point to use is the origin if it's available, okay? So notice it says that when I pick a point, it can be anywhere, or I could actually use the origin as long as it's not included on that line. Okay, so if I wanted to use the origin, then it says I want to write it in point slope form and then convert to standard form. So really number two has a couple of things to it. I've got to choose a point and write an equation. So actually I think what I'm going to do is I'm going to go ahead and label that as number 2 and 3, and 4 will be convert to standard form. Okay, and so it shows us, erase this real quick. It shows us an example of this. So if I look, the first thing I want to do is to find my slope. So I look and go from this point here to this point here. I go down 1, 2, 3, -3, 1, 2, 2. So my slope is -3 over 2. I know that if I'm going to write an equation of a line that is parallel to that, then my slope is going to be the same. So I don't have to worry about the negative reciprocal here. I'm going to have the same slope. So it says the slope of a parallel line is also -3, 2. Then it says choose any point not on the given line to write an equation. So it says to use the origin if I can. So that's what I'll do. And so here they plugged in the origin to point slope form. So number 2 was to use my origin. There's my point. So we said step 3 would be to plug it in. Y minus 0 equals -3 halves x minus 0. And now I'm just going to plug that in. Remember, if I have minus 0, I'm just going to have y is equal to negative, whoop, I put that wrong, hang on. My parentheses need to be around my x minus 0. So again, when I simplify, I end up with y equals -3 halves x. I need to go ahead and multiply everything by 2. 2y equals -3x. Add 3x to each side. 3x, that's a y, plus 2y equals 0. And that's where we ended up over here, okay? 3x plus 2y equals 0 is my standard form, so that's step 4. Okay, so now what we're going to do is activities 2 says write the equation in standard form of a line through the origin parallel to the given line. Oh, let me get Sadie back in. Okay, so let's look at this one right here. Step 1 is to find my slope. M equals something. I'm going to start here, end up here. I want you to calculate the slope. What is the slope of this line? Okay, did you notice that I go down 3 and then right 3? So that's -3 over +3, and a -3 divided by 3 is -1. So I would simplify that. Remember, anytime I'm dealing with a fraction, I always want to put it in simplest form, even if I'm talking about the slope. So if my slope is -3 over +3, I simplify that to be -1. Okay, so that was my first step. Second step, remember, I want to use my origin as long, and then my directions tell me that I'm writing an equation of a line through the origin. So that's what I'm going to do here. My point that I'm using is my origin. Step 3, I need to use point slope form. So I have y minus 0 is equal to -1 times x minus 0. So now I need to get ready and convert that to standard form. So that means if I just take my zeros out, the reason using the origin is so much easier because y minus 0 is just y. And then -1 times x minus 0, when I distribute that -1, I'm just going to have -1x, okay? Because that would be -1x plus 0. So it just ends up being -1x. Now to convert to standard form, I need to move 1x over. So I'm going to have x plus y equals 0. And that's all you do. Let's go ahead and look at the one next to it. Going to do the same thing. First thing I need to do is to find my slope. If I go from this point to this point, I'm going up 1. So that's a +1. And then right 2. So that's +2. So I've got 1 over 2. So my slope is +1/2. Again, it tells me I want to use the origin. So now I'm going to plug it into point slope form. Y minus 0 is equal to 1/2 times x minus 0. So y is equal to 1/2 x. Now, I can either eliminate my fraction first, or I can move it. Either way, I'll go ahead and move it first. So I'm going to subtract 1/2 x from each side. So I have -1/2 x plus y equals 0. So now I can multiply everything by 2 to get rid of that denominator. But I'm also going to multiply it by a -2 because I want to get rid of my negative sign as well. So a negative times a negative is a positive. So I'm left with just 1x minus 2y equals 0. So x minus 2y equals 0. Because remember, I'm multiplying -2 times -1/2 x to make it positive. That means I have to multiply -2 times a positive y, so it becomes negative. And then -2 times 0 is still 0. Okay? So let's go ahead and Lesson 44 is just writing linear equations from graphs. And so basically that's what we've been doing this whole time. is we've been looking to see what information we know from the graph. And so what it says in this lesson is it just says, you know, when you're writing an equation from a graph, look for some shortcuts, okay? Is the line horizontal? If it is, you know it's just going to be y equals something. Is the line vertical? If it is, you know you're just going to have x equals something. If you have the y-intercept, you can use slope-intercept form. If you only have 2 points, then you can use point-slope form. Okay, so that's all basically what we've just been doing through all of this. So let's go ahead and kind of like I said, I'm not going to have you guys do perpendicular and parallel lines on your test. So we're just not even going to worry about activities 2 on page 98 let's go ahead and look at activities 3 on page 96 for a minute. Okay, this is page 96, activities 3. Notice my directions say write an equation in standard form of a line through point -1, 1. A minute ago, they told us to write our equations through the origin, which was 0, 0. So this time they tell us to write it through point -1, 1. So if we look at activities 3, if we're just going to look at the first one and do an example with that one. So I have, first of all, I want to find my slope, m equals. Notice to get from one point to the other, I can either go up to, right to, or I can go down to, left to. So I can either go up to, right to, or I can go down to, left to. Either way, 2 divided by 2 is 1, and -2 divided by -2 is also 1. So my slope is just 1 there. Okay. Now, the point they've told me to use is point -1, 1. So when I go to step 3 and I use my point slope form, I'm going to have y minus 1 is equal to 1 times x plus 1, because I'm plugging in my values. So now I'm going to distribute. Y minus 1 is equal to x plus 1. Now I need to go to standard form. Subtract x. I have -x plus y minus 1 is equal to 1. Add 1, -x plus y is equal to 2. I know that x cannot be negative, so x minus y is equal to -2. Okay, so basically all they did was say, hey, in step 2, use -1, 1 as your point. Okay. I think what we'll do is let's go ahead and stop and take a look at what assignments we have had for our graphing section. Before I move on to lesson 45, I want to go ahead and kind of get all this wrapped up. On your test on Thursday that I'll be sending home, you will look at equations and graph them. Then you will look at a graph and write the equations, and all of it will be written out, and we'll go through that in just a minute. But first of all, I want to make sure that we look through what assignments that we have done that will be handed in with your test on these sections. Okay. So the previous Monday that we were at the co-op, we turned in lessons 31, 32, and 33. Okay, so let's flip back for just a minute. We had 31, 32, and 33. And I'm going to look back. I need to remind myself what we actually did for homework and what we did just in our book, because I know we did a bunch of it just in our book. Let me go back. That's the wrong one. Nope, not that either. All right, so 31, 32, 33, we've already handed in. all that came in. Now this should be, I think that was the same page. Okay, lesson 34. I think we did all of this in the book, and y'all just somebody unmute and tell me if I'm wrong about this. I think lesson 34, we did all of that in the book, and we did not have any homework. Is that correct? Okay, so lesson 34, we don't have anything that'll be turned in. Let's look at lesson 35.
It starts at lesson 38.
Did we do all of lesson 35 in class as well, or did we have a homework assignment on this one? Is there anything to turn in for lesson 35? I was thinking not.
No, ma'am.
All right about that? Lesson 36, we were dealing with perpendicular lines, and it looks like we had numbered these. But for some reason, I was thinking we did them all in class. So from what I can tell, it looks like our first bit of homework that was actually to be turned in is page 84, which goes along with lesson 38. So lesson 34, I'm sorry, lesson 38, page 84, activities 3, numbers 4, 5, and 6. Okay, that'll be the first thing that needs to be handed in. Lesson 38, page 84, activities 4, 5, and 6. And then activities 4, we numbered them 1, 2, and 3 at the bottom. Okay, so those last 3 on the bottom on page 84. Okay, so that was all on page 84. We have, let me put a little, we'll do a different color here so y'all can see what I'm talking about. Okay, so we had 4, 5, and 6 here. And then we numbered these 1, 2, and 3 on the bottom. So we've got 6 total problems on page 84. Okay, and then the homework that we just checked a moment ago was page 86. Let me go back to that one. Oh, I don't have it in here. So then we had page 86. So let's do this. Cancel. Okay. All right, so today is 11/30/20. Homework to be turned in on, nope, it'll be 12. Was that 12/7/20 is going to be lesson 38, page 84, activities 3, numbers 4, 5, and 6. And then activities 4, we've got them numbered as 1, 2, and 3, and it's the last 3 on bottom for each activities. Okay, so activities 3 and activities 4, it's the bottom 3 problems for each one. Okay, so the first thing you'll be turning in is lesson 38. And then the homework that we just checked that went along with Let's see, page 86. Lesson 39, page 86, activities 3. And then activities 4, we had numbers 4, 5, and 6. Okay, or that was the last 3 on bottom. And then lesson 40, page 88, activities 2. The homework that I've given for today was page 92, and that goes along with lesson 41. Page 92, activities 2. Okay. This is what will all be turned in next Monday. Okay. I will send this in an email also this afternoon. All right. Now let's go ahead and talk about what will be on our test. Okay. Again, I said that there would be, we would be looking at graphs and being able to write an equation from a graph. We will also be graphing information. So let's go ahead and take a couple of notes for what will be on our test on graphing. All right. You will need to know how to graph points on a line, or we'll just put graph points. Okay, remember that's going to be X and Y. Okay, you need to know how to graph a point. You will need to know how to find the slope of a line. You can either count it if you can, or use m equals y2 minus y1 over x2 minus x1. You will need to know how to, from lesson 30, how to plug in values of x to solve for y and graph. Okay, so on lesson 30, that was where we set up, remember they gave us a T-chart, but I actually made it into an extra chart. I made it 3 columns because I like to go ahead and have the X and Y points at the end to be able to graph it. So lesson 30, plug in the values of X, solve for Y, and then graph it. I've already said you're going to need to find slope. That's from lesson 31. You are going to need to know how to write the equation of a graph using slope intercept form. Y equals mx plus b. Okay. You're going to need to know how to graph that. To do that, first you graph the y-intercept. then you use the slope to find additional points. Then you connect points with a line with arrows. So using slope-intercept form, if I give you an equation, I need you to identify the slope and the y-intercept. You need to graph the y-intercept, then use the slope to find additional points. Connect that points with a straight line, arrows on the end. The next thing is going to be from lesson 33, and let's see, that was lesson 32. This is lesson 33, point slope form. Point slope form is where I have y minus y1 equals m times x minus x1. In this example, you will need to identify the slope, identify a point on the graph, and then graph the line using point and slope. You will need to know from lesson 34 that a horizontal line has slope equal to 0, and a vertical line has no slope. The only thing that you need to know about from lessons 36 and 37 is that parallel lines have the same slope and perpendicular lines have slopes that are negative reciprocals. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. From lesson 38, you need to know the rules for standard form. AX plus BY equals C. And that is A must be greater than 0. No fractions or decimals. And then a combination of lessons 39, 40, and 41. You need to be able to identify points and slope of graph. Write as either slope-intercept or point-slope forms, and then convert to standard form. So those will be the things that will be on your test, okay? Please be sure to let me know if you have any questions on how to do something. If you're just still kind of hung up on something, let me know. We'll set up a one-on-one Zoom. Usually for those of you that I've worked with, we'll log in and it may be 20, 30 minutes and we're good to go, okay? So it usually doesn't take very long, especially when it's one-on-one, and I'm able to kind of see what you understand and just explain a part that you may be struggling with, and we just move on, okay? So do not hesitate to let me know if you need any help. What I'll do, since I feel super disorganized today and I feel like I'm just still not on top of it yet from being off for the week, I'm going to type up these notes and I will email them to make sure that you got all this information. Okay, I'm going to send you a note of what will need to be handed in on Monday with your lesson work so you can make sure you've got all that wrapped up. I will send you these notes to study, to know what you need to know for the test. The test will come home on Thursday. It will be handed in on Monday as well. Okay, so your work that I'll have on this list or that we've just written down and your test will be due on Monday. Okay, now on Thursday, we'll be starting our new unit. I'm going to be emailing you. Actually, no, I won't. What we'll do is I'll just go ahead and on the Monday that we return, I'm going to have an inequalities packet that we're going to be working out of. I'll just wait. I won't even email it to y'all. I'll just copy it when we get to the co-op on Monday and give y'all that. But we will go ahead and start our inequalities unit. And then that will be kind of what we finish up with for the semester. That packet will be for a test grade, and then that way you don't have to worry about getting a test done and sent and all that stuff before we get out for Christmas. So we will have this test grade, and then we'll have the inequalities packet that we'll be doing. This homework that I've just told you about will be the last homework that you will hand in for this semester, okay? Take your time, make sure you've got your lesson notes, make sure you've labeled it all, make sure you've checked it all. Make this homework, make sure you get 100% on it. There's no reason for you not to get 100 on it, okay? Remember, it is due next Monday. I will not take it. Well, I mean, I will take it late, but it'll be counted the points off, okay? So make sure you get that turned in. Any questions before we get ready and go? All right, like I said, I will type these up and send them to you this afternoon so you'll have everything. Make sure you study your equations. Make sure you study and you know what point slope form is. I will not be putting it on the test. You must know these equations, okay? So when I say write the equation in point slope form, I'm expecting you to know that point slope is y minus y1 equals m times x minus x1. If I say write it in slope intercept form, I'm expecting you to know that that is y equals mx plus b. My recommendation is make you some note cards. Write an equation on one side or flip it over and write the name of it on the back side so you can just flip them and memorize them just like you did flashcards with times tables, okay? Same situation, just memorizing these are going to help you, all right? These are things that you'll be seeing again, so you need to know them. All righty, So your only homework is to make sure you get ready for your test. And this, what was it, page 92, activities 2. Okay, so not much homework, not much to do. So make sure that by Thursday you have finished page 92, activities 2. I will send you the answers for that so you can check that. Let me know if you have questions, and we'll wrap up graphing on Thursday. Okay. If you have questions, feel free to stick around and ask them. If not, you are free to sign out, and I will see y'all on Thursday.
Bye, Miss Jen. Thank you.
Bye.
Bye.